Hi, everybody. Hi, Glenn.
Hi, Christopher. Thanks for joining us.
Do you want to introduce yourself first?
Well, my name is Glenn. I'm one of the members of the Azure user group. I'm also founder of Azure Belgium. And in my day-to-day job, I'm working with Azure, focusing on IoT and on all the cool stuffs in Azure. So that's why I invited you to join this show, to also introduce yourself to the community in Belgium. I know you're fairly new in the EMEA area, especially focusing on IoT. So I'll let you take it away, introducing yourself and what IoT has to offer from Microsoft's side, and then I will take over and talk a bit more on digital twins.
Great. Thank you, Glenn. Hi, everybody. My name is Christopher Manner. I'm a startups cloud advocate at Microsoft. I'm actually based near Belgium. I'm in Paris, in France. And as you said, I'm leading our IoT advocacy efforts for the EMEA region. So you may have seen me on some previous events in Belgium when we had the opportunity to travel, or before I joined Microsoft, I've been for several years Microsoft MVP before joining the company. So we do a quick introduction about what is IoT and why you need something in Azure to actually do IoT things. And then I will hand it over to you, Glenn, to talk a little bit more about one of the products we have, which is Azure Digital Twins. Before starting, my slide will be available at the end of the presentation, and I'm monitoring on the side YouTube, Twitter, and Facebook. So if you have any question, feel free to ask them there. I will answer after my presentation. So Internet of Things, let's start with that, because there is a lot to say about what actually is Internet of Things. One of the definitions we can give to Internet of Things is quite simply things that communicates via a digital network. So it's quite obvious based on the Internet of Things name, but we will go a little bit deeper onto these words and understand what's behind it. So when we say things, maybe the first idea that comes in mind is having some chip, a microcontroller, or even a Raspberry Pi sitting on your desk that communicates data like temperature to something in the cloud. But actually, we need to broaden our vision when we say things, because we can actually connect a lot of different things with different form factor, different used, and also old things and new things. So when we talk about Internet of Things, we also include products like the HoloLens, holographic headsets, or even some drones. We have a company in France that are creating an Azure IoT connected drones to do a lot of surveillance and monitoring farms, etc. Or simpler, some camera. Here is a picture of an Azure Kinect. So it's an AI-enabled IoT camera, but we can definitely connect or consider as IoT a lot of different security cameras already existing. But we also need to think about entire manufacturing floors that can be one big or a group of thousands of Internet of Things connected devices. Or we can also do, and it's done quite a bit, what we call IoT retrofitting, which is basically taking an existing hardware and just adding a bit of things on top of it and connect it to the internet and try to augment an existing object through IoT. So here you have a picture on the right of an air compressor. It's for scuba divers, and if you want to learn more about how I've connected this old air compressor, I encourage you to check out the video. You have the link there, and I will copy paste the link on YouTube, Facebook, and Twitter. So when we say things, we really mean a lot of different things, and not only a smartwatch or a connected speaker you can have on your house. The second part is that communicates, and that seems obvious at first because if we take, for example, the Raspberry Pi, we can connect it to Wi-Fi or to a wired connection. But in the IoT space, sometimes you don't have access to this kind of connectivity. So you need to rely on 3G, 4G, and in a few months, maybe a 5G connectivity. But even if you include 3, 4, 5G Wi-Fi and wired, this kind of communication mediums requires a lot of power. And some IoT devices need to be plugged somewhere, for example, in a ceiling, and be the battery that gives 1, 2, 3 years of battery life while communicating. So obviously you cannot put a 100 kilo battery on top of a temperature sensor to get it running for years. So we need to actually switch to other way to communicate with these devices with very specific type of networks, wireless networks. Sometimes we call them the OG, 0G networks that actually gives very, very minimum amount of bandwidth, but connect this object to the internet and still get a very, very low power consumption. And then we even have in the IoT space some devices that absolutely don't connect to any internet network. And for using them, we most of the time use what we call an edge gateway, which is basically a box that allows communication with a group of devices over a wide range of mediums. It could be a wired non-Ethernet system, serial, for example, or it could be also a Bluetooth or other way of communicating. And this edge gateway is the only piece of component that gets connected to Internet. And we also more recently broadening our vision of IoT to include what we call edge, and specifically edge servers. So, for example, if you're in an organization who has branch offices, maybe some of the servers in these branch offices could be considered as edge servers and rely on IoT technology to get updated, to run software, to send telemetry back to the headquarters, etc. So basically, we have a lot of different things that communicate in a lot of different ways through a digital network. But for doing what? And the value of IoT solution mainly comes from 2 different things. The first one is the cyber model, which is basically a way to represent how a specific IoT device is functioning, and the ability to change the way it's functioning from a distant way. Let's take, for example, a dishwasher, an IoT dishwasher. First step is to get this dishwasher smart. So we basically put some microchip in it, and then you can have access to a lot of different features, like different cycles, washing cycles, like eco cycle or very dirty cycle, that kind of things. And you can maybe schedule in 4 or 5 hours the start of this dishwasher. Then you can go on the next stage, which is connected dishwasher. And actually, there is a lot of objects right now that we call IoT, but are really just connected objects and not IoT objects. And these connected ones are still have some intelligent features because they have a processor in it, and also they are connected. So, for example, they can send you notification of your phones, but that's it. And then if we go a step further, we have the IoT dishwasher. And through the IoT dishwasher, because it's connected to a global system, an IoT system, we can do intelligent things like, for example, pushing a new program onto this device for having a COVID-free dishwashing system, a new program that didn't exist when you buy this dishwasher, or having a more intelligent way to run this dishwasher. For example, you can program this dishwasher to finish at a maximum at a certain time. And then you let the dishwasher decide when it's the best for the environment to actually start working. So you can connect to information about the electricity grid in your country or in your city and actually launch the dishwasher only there is a maximum amount of renewable energy within the grid system. So it's a very advanced system, but it's actually, we've been able to modify the way these devices actually working by connecting it to an IoT system. But it's only a part of the value provided by IoT solution. The other parts, it's all the analytics we get from them, and also all the predictive maintenance or all the AI we can build based on top of the data. So when we deploy a new IoT solution, there is a lot of say on the IoT side of things and devices side of things, but we should not forget about the analytics side of things. Mostly it's big data systems, and what we saw, it's most of the time when you're starting a new IoT project, you tend to forget the analytics thing, but it's a quite huge thing to implement, to have a real impact with your IoT solution. However, creating your IoT project is quite complex. There is a bunch of challenges, and you have here at the screen only few of them, like security or scaling your IoT. It's a thing to deploy 3 Raspberry Pis in your home. It's a different story to deploy 1 million devices across the world or across the country. And that's why we may want to use some cloud solution like the one we have in Azure to actually help you secure your entire IoT lifecycle, to help you scale your deployments, and also to help you connect all the data and the action and insights you get from your IoT deployments to your existing business application and business databases. So to give you a quick introduction about the Azure IoT landscape, because we have a huge number of products that are directly or somewhat related to IoT in Azure. The first one will be IoT Central. It's a managed solution. So basically, you can find devices that are already certified for IoT Central. And we have a bunch of different ones like proximity sensor, counting people, connected cameras, humidity, temperature sensor, so on and so on. And with this device already in the catalog, you can directly connect them to IoT Central with a very minimal configuration. So even if you don't know nothing about IoT, you can actually deploy an IoT solution with IoT Central and these certified devices. And you get a dashboard. You can export your data to Power BI, to blob storage, or you can send alerts to different business application directly from IoT Central. So if you're getting started, it could be a great way to have a first foot in the IoT space. Then maybe you want to build your own solution, and if so, I encourage you to check out some of the solution accelerators we have. They are limited to a certain type of IoT deployments on some specific industries, but maybe you will find what you're looking for in this solution accelerator. And if not, we have a bunch of different services that allows you to manage the device supports, to gather and query and analyze data, and also to visualize and integrate what you get from the IoT, mainly the insider data, into your existing business applications. As you may have seen while I'm talking, there is a small animation. We have a bunch of different products to actually do it. The first one is Azure IoT Hub, but for each section, device support, data analytics, and visualization integration, there is a lot of different products that can help you. And as I said, we have a bunch of products around the IoT Edge, including a version of Windows 10, including a version of Azure SQL that runs on devices with a minimum of 1 GB of RAM. So you can actually run Azure SQL Edge on Raspberry Pi. We obviously have partner solutions, and one of the last one I will mention here is Azure Sphere, which is related to security. I don't have time to go over more details about Azure Sphere, but if you have any question, feel free to ask me. If you want to learn more about the different components of an IoT solution, I encourage you to check out a new learning path my colleagues and me have just released. You can find it on GitHub on aka.ms/IoTLP. And again, if you have any question, feel free to reach me out on Twitter @Simane, or during this live stream, I will be monitoring YouTube, Twitter, and Facebook. And with that said, the floor is yours, Glenn.
Yeah, thank you, Christopher. So as Christopher already mentioned, IoT is all about having your things that are communicating, and then processing data, doing some analytics on that data. So that has been the main focus for quite some time in the IoT solution. So having those assets connected, transmitting data to the clouds, doing analytics on top of that. But we see that there's a couple of new trends emerging while building IoT solutions. So customers really are trying to build out or to model their physical environment first, and then mapping different kind of sensors on top of that. So first, the focus is having that no longer that connected asset, but really having that environment connected. Think about having a seat reservation during this COVID times, or constantly monitoring the air, processing data towards the fan system to improve air quality. So we're really talking about having those connected environments. So it's all about virtually connecting the physical world and keeping the model that is behind that thing, keeping it up to date with IoT data, so that IoT solution is more context aware of your people, places, and devices. So you can really create that those more connected environments and bring better experience for the people in the environment. And this is where actually the new this is where the new Azure Digital Twins come into play. And I think Azure Digital Twins, the refresh was announced earlier this year. It has gone through quite some stages. The main difference between people that worked with version 1 and version 2 is that the modeling is now based on an open standard. There's more flexible topology definition possible. In version 1, the compute that was inside Digital Twins was JavaScript based, while now the new version of Digital Twins really has the compute externally. So you can write your own code, for example, bring your own compute, write data in functions or wherever you want it. In version 1, the IoT Hub was baked into the system, while now it's really external from the service itself. The service itself is now really a sort of enabler of building those IoT ecosystems for digital twins and those connected environments. So the service is currently still in preview, but I think at Ignite, Sam announced that the service will go GA somewhere this month. So I'm expecting that within this and a couple of weeks that the new digital twins will go GA, and that you can start using that. In the meanwhile, the service is still in preview, so we'll take it from that. So let's first of all talk about the open modeling language. You can create a digital twins, or you can describe your digital twin based on what is called the digital twin definition language. It's based on JSON LD, and it's basically it's based on a standard that is used across the different IoT services within Azure. For example, IoT Plug and Play is using the same definition language. Time series insights also support that language. And it really allows you to describe your digital twin based on a set of properties. A property, you can see that as a data field, and that data field has a certain state onto the digital twin. So that property is really backed up by backend storage and is saved onto your digital twin. You can add descriptions in forms of telemetry, and telemetry is really telemetry as you know it. So it's measurements, events, sensor readings. An important difference there, telemetry is not stored on the digital twin itself. You can see it as a sort of stream that is flowing through the system, and it's not stored on the twin itself. And then components. Components allow you to build model interfaces. You can think of that if you want to describe a digital camera, you can a digital cell phone, for example, or a digital smartphone. You can define a component as a camera and then use that camera as front camera or back camera. So it's really writing those interfaces, allowing you to build a better digital twin definition. And then, of course, the most important thing is the relationship. And the relationship is that describes the way how twins are interacting with each other and what the relationship is between the twins. As already said, the digital twin definition language is aligned with IoT Plug and Play and time series inside data model. And of course, the relationships are then used to create a graph of the twins. But I will definitely come back to that later, where I will show you how the actual visualization and how you create those digital twins. The next important part is the live execution environment. So, as already said, twin instances are connected with each other into a twin graph with their relationship. You can visualize that with a tool called the Azure Digital Twin Explorer. Currently, this is just provisioned for you as an open source product. You can access that through GitHub. Currently, it's not available in the Azure portal itself, but it has been built by the Azure IoT team, so it's backed up by that. As already mentioned, the eventing, data processing, updating of the twins is done through external compute. So what the Azure Digital Twin actually is, it's a set of APIs where you can define twins, relationships with them, and keeping those twins or up to date with data through external compute by calling APIs. This can then further be used to drive business logic, further data processing. You can extract the data that is being processed inside digital twins to external analytics and so on. There's also a quite rich query API where you can live query the environment with all the necessary things. And of course, you can have input with IoT Hub or other data sources, as long as you are able to communicate with the API behind digital twins. You will be able to update the data. As already mentioned, you can route data that is being processed in digital twins throughout other systems, and it supports Event Hub, Event Grid, Service Bus to really connect other systems that are able to process data that is inside your digital twins. There's a couple of endpoints that allow you to build upon that data. For example, you could store the raw data in data lake, or you could connect to logic apps to trigger an external business processing system. You can connect to time series insight for your historical series of data and so on. So with that said, let's immediately jump to the demo, as there's quite some stuff to show. So I will give you first of all an overview on how to build a model in digital twins. So that will be the main focus over here. So I will show you how you can build a model, update that model towards digital twins, create your digital twins, and create your relationships with them. Then I will show you how you can, by using well-known IoT services like IoT Hub, I will have simulated devices processing data towards IoT Hub, and using Event Grid, I will call my external compute and update all my data in digital twins. What I've done then is in digital twins, I've created an endpoint that will transmit or export all the data that is flowing through my digital twin. It will output that data towards an event hub, and then I can show you that data that is running inside my digital twins. And on the bottom, excuse me, on the bottom, I will show you the process on once you have modeled out your digital twins, on how you can update that model towards digital twins and basically build your own digital representation of your environment. So let's quickly jump through the demo. No, that's not the correct one. So what I did as an example here is I've modeled out my my house. So it's my new working environment for quite a long time, and probably will be for the next couple of months. So what I did as a matter of demonstration is to model out the house and really create my digital house actually. So what I did is I've started, of course, with my house. So my house itself is the main level. So and then I've started modeling it up, defining the floors, the rooms, and so on. But let's just take a look on how a model or the model should look like when you try to build up that house. First of all, there's the ID here. It always has to start with DTMI. Then you can define your a domain that can be really anything. In my case, I'm using the demo domain, but this can be, for example, your customer or anything like that. Then you define a model identifier. In my case, I'm modeling my house, so this will be my my model identifier. And as a last one, this is my version. So I'm still at version 1 of my house. I'm not planning any reconstruction, so this is still version 1. So then the type, it is always interface in the case of digital twins. Then display name is just a friendly name that allows you to have a more display friendly name of your ID. And then the context here, that's also quite important. This is a fixed value that is necessary for digital twins. So what is really the most important when you start the definition is the display name and the ID. That are the most important things. all the remaining interface data that you are defining is actually inside the array of the contents. And as you can see here, I've added a couple of items there, and I want to point out here that I've added the properties. I added two properties, one construction year and one owner. So every time I will create a twin of my house, I need to define an owner and a construction year. Remember, during the slide, I said this property is actually a state of the twin. So that's actually stored on the digital twin itself. And then probably the interesting one is that my house has a relationship that is named floor, and that is targeting another ID of my digital twin. So if we would take a look at the model that is defining my floor, you would see here that the IDs are matching. So really the target is specifying your ID of your relationship. So again, same mechanism or same approach when defining the floor. I'm giving it an ID, giving it a proper display name. There's nothing much to say about a floor in a house besides the fact that a floor has a couple of rooms. So the only thing I mentioned here is my floor has relationships with the rooms. So again, a little drilling down a bit in the model, again, defining a room. So this is just a base model of my room. So my room has an ID, it has a display name. Here I've added two properties. It has temperature and humidity. So you're probably wondering, okay, Glenn, why is this not a measurement? So what I'm doing here is I'm adding these properties towards that room because I will update this properties with the sensor data that is flowing through my digital twin, and I will actually at regular intervals update this property with the live data that is flowing through the system. So I actually have that data then backed up in my digital twins. So then as a relationship in my room, I have a sensor, and my sensor, as you can see it has the sensor, and then it has a firmware version, and then it has two type telemetry versions measuring the temperature and the humidity. So, and that's the way how you start modeling out your digital twin. Once you've modeled that out, you can upload that model towards the digital twin environment using the API, and that would look something like this. So I'm using the Azure Digital Twin Explorer that's running on my local environment, but it's connected to my digital twin environment in Azure. If we would, so this is available on GitHub. So if you look for Azure Digital Twin Explorer, you will definitely end up on this page. So as part of preparation, what I did, I've already uploaded the different models towards my digital twin. As you can see here, this model is now available for me to use within digital twins. So, and the question now is how do I start modeling out that? How do I communicate with Azure Digital Twins? So before we do that, let me just quickly jump to Azure Digital Twin itself on the Azure portal. So if you provision an Azure Digital Twin, what you will get is you will get this, this area, and the most important for you will be the host name. The host name behind the scenes will host for you the APIs where you actually will communicate with. What you need to do is then you will need to create an Azure Active Directory application, give it the correct access rights upon your digital twins, and then before you communicate with the API, you need to authenticate, and then you can start talking with the API by using. You can use the SDK or talk directly with the APIs. So what you get in Azure is just a service with a couple of blades. I will come back to those later, to this one later, showing you how to connect certain outputs. But the inputs itself, as the service mentions, is done through the REST APIs or by using the SDK. So if we now take a quick peek at the SDK, so I don't want to go very much in details about that, but there's a couple of things you need to know. So this is a set of code to allowing you to create a digital twin. So what you need to provide is a set of metadata. First of all, you need to define, given your model, your kind will be a digital twin. And then that metadata you need to add into another dictionary where you add your metadata as a single value, and then you can add your properties as you want. Remember, our house had construction year and owner as a property. So once you have that, you can use the digital twin client that I provisioned at the top to create a new digital twin. So what I need to do is I just need to provide a digital twin ID. That digital twin ID I can choose, but that will be my main ID where I talk to when communicating with the digital twin. And then I need to give it a string, a JSON string having the metadata that I want. And this is basically how you create those twins throughout the system. So here I created a floor, floor 1, floor 2, floor 3. As you can see, I only need to create this this metadata once, because it's actually 3 times the same floor, but with another ID. Same for the rooms. I've created those rooms again with the same model, the same data, but every time a different ID: kitchen, living room, bedroom, and so on. Same for the sensors and so on. The next thing you have to do is to define the relationships. And again, this is the same way you will approach the creation of the clients, of the digital twin, sorry. You will talk with the digital twin clients, but then you will use the create relationship async. And what do you have to mention over there? First of all, you need to mention your digital twin ID. Here I'm saying, okay, remember I created a digital twin with this ID. I need to give it an actual relationship ID. So I will just call this localhost to floor 1 as an ID. And then I need to give that a relationship, a JSONized relationship string that is mentioning my target ID and my relationship name. Remember, my target ID is the ID of the digital twin, and the relationship name is the name that is defined inside the model that needs to be used. And that way you are modeling out basically your entire twin. You are creating relationships and so on. So if I would run, let me just go back to the Digital Twin Explorer. If I run this query now, you will see that my graphical view of my twin is still empty. So if I would run this now, let's see how hard I broke my demo by modifying that code. So what I will do is set up Digital Twin, and this will now run through my code, create the twins, create the relationship. And if all goes well, we should see something popping up in the Digital Twin Explorer. As you can see here, I need to authenticate. Authentication complete, so that's already good. Let's go back to the console app. I see there was an error on top of that, but that's probably related because of the models that were already there. As you can see here, first of all, what I'm doing is I'm creating my set of twins, and then I'm creating the relationships between them. So if I run the query now, if all goes well, he should start modeling out those values. So this is now a graphical interface of my digital twins environment. If I would click these twins on the side, you would see that that the metadata has been filled in. So construction year, I'm the owner of my house. On the floors itself, you would not see any metadata, only some data of the model. The rooms, remember, should have temperature and humidity. As you can see here, these are currently at 0, as we are not updating them. Same for the sensors. So now we have modeled out our digital twins, and we are ready to start feeding data towards that interface. So how do you do that? So as already mentioned, if you want to use, if you want to connect your inputs to digital twins, you need to use the REST APIs. So there's no direct way of hooking up IoT Hub saying, okay, now feed all my data towards digital twin. That's currently not possible. So how do you do that? In IoT Hub, you can set up events. And if we would click that, what we do is we defined a filter on device telemetry, and we're outputting that to an Azure function. So every time there is telemetry inside of IoT Hub, we push that message towards Azure function, and Azure function will be responsible for processing that data, calling the APIs of digital twins, and updating the digital twins with the data. So let me just quickly show you the code of that. So as you can see here, I'm subscribing to digital twins, and I'm just reading reading the properties here, and I'm just updating the twin properties using the client, saying update digital twin, giving the twin ID, and just providing the path and the value being being the humidity of the twin with the correct value. So what I'm doing here is taking the IoT Hub message, giving it to Azure Function, and Azure Function is calling the APIs behind the scenes to update the values inside my twin. So what I also did in IoT Hub is define a couple of devices. So I have my devices here, and what I will do is I will start my device simulator here, because that's the way we do IoT demos with simulators. So if all goes well, that should pop up soon. Kind of lost my console. Oh no, it's there. So as you can see here, I am now processing messages towards IoT Hub. So what will happen? IoT Hub, every time it will receive a message, it will, through Event Grid, output the message towards Azure Functions. Azure Functions will pick that up, call the Digital Twins API, and update the model. So if you want to visually see this, we are running the simulated devices, processing the data to IoT Hub. IoT Hub is, through Event Grid, pushing messages towards Azure Functions, and Azure Functions is using the APIs of Azure Digital Twins to update the data. If we would go to our Azure Digital Twins now, and if we would click on the thermostat, you would see that these values are being updated. So you see that temperature is coming through for all these different things. So that's the way you put in data inside IoT, inside Digital Twins, excuse me. So the next question is, you have your data flowing through the system. How do you extract data from the environment for you to use in your analytics and so on? Inside Digital Twins, there is what is called the possibility to add different endpoints. In our case, I have an Event Grid endpoint and an Event Hub endpoint, as shown to the demo. But if you want, you could also create a service bus and so on. So think of these endpoints as, if you're familiar with IoT Hub, think of these endpoints as kind of like IoT Hub endpoints. The next thing, once you have defined your endpoint, you can start defining event routes. Again, very similar like you do with IoT Hub. You have you can create an event route, but first of all, what you need to have is an endpoint defined, so Event Grid or Event Hub. And then you can start, you can start to select on what data you want to see on that event route. So you want to see messages when the twin gets created, when the twin get updated, if you see updates in the relationships, if you want to see telemetry messages being passed, and so on. So, and this is also the way how you extract data towards external system. In our case, if you remember the slides, I have defined an Event Hub endpoint. What my Event Hub endpoint basically will do is we will extract data towards Event Hubs, and that Event Hub will act as input towards for my time series insights. So that demo, that endpoint has been set up. So if we would go and take a look at time series insights, if all goes well, we should see some data inside time series insight of our demo. So what we can do is I will just add the temperature here. So it's a small amount of data. So let me zoom in. So there has been some data flowing in into the system now. So, and this allows you to really start extracting the data from your environment. So looking at the time in time series insights, we're almost coming to an end. Let me jump back to the slide deck. If I find it, yes. So coming to the conclusion, so Azure Digital Twin is enabling you to really start building those next generation IoT solution where there is more a focus on the environment, on modeling out your environment, your places, how things are interacting with each other. And it's Digital Twins is built around that event-driven approach. So as already mentioned, there is, for example, no direct connection with IoT Hub. So you really need to process events and call the APIs of Digital Twins. So it is really focused around those REST APIs and providing you with a great set of REST APIs to update that model, keeping that environment up to date, and to get data out of the model and using that to build your IoT solutions or your IoT environments. With that said, I'll open up the floor for questions. If you have any questions for Christopher or me, do not hesitate to ping us. If not, I would like to thank you for attending, but let's keep the floor open for some questions. I don't know if